Okay, we've got an equation, it tells us roughly where a root is, and we've got to use the Newton-Raphson procedure, okay, which is in your formula book. Okay, it gives us a starting value. We're going to find the root to 5 significant figures. The thing given in your formula book looks like this. Okay, so the relevant bit, this is on page, what page number is this? I'll look it up in a minute. This is the relevant bit about the Newton-Raphson iteration. Okay, so here's the formula we use. That helps you set up the iteration. But this is good as well. It tells you that you have to have an equation in the form f of x equals 0 before you can set this thing up. So we're going to be using that. Let's just scroll down. That's page 7 of the formula book. Okay, so you need to be aware it's there. Okay, so the first thing the formula book told us we need is an f of x which equals 0. So this is the same as you'd need for the sign change method. So this hasn't got 0 on one side, so I need to rearrange it till I have. So I can have x e to the x, I can take away the 3, I can take away the sine x, and then it does equal 0, so I can call this f of x. So I've used that first bit of help from the formula book. The second bit of help from the formula book was that xn plus 1 equals xn minus f of xn over f dashed of xn. Okay, and you don't have to memorize that formula. You do have to know that the way this works is that it imagines the graph. So if you've got the graph going on, if we've got something that is near a solution, then what the Newton-Raphson method does is it draws the tangent in to the nearly solution we've got, and it finds out where it follows that tangent back to the x-axis, and it finds a nearer solution. In fact, usually it's a nearer solution. It's not guaranteed. But anyhow, in this particular question, we just have to be able to apply the formula. So I've got x, that's not going to be a problem. I've got f of x, or f of xn, that's not going to be a problem. F dashed I need to work out. So I've got f of x is this thing here. So f dashed of x, I just differentiate what I see. Oh, x e to the x is going to require a product rule. So I've got a u equals and a v equals, because it's an x times an e to the x. So u is going to be x, v is going to be e to the x, u dashed is going to be 1, v dashed is going to be e to the x. So I've got to do u dashed v plus u v dashed for that first bit. So the u dashed v will give me e to the x, plus uv dashed will give me x e to the x. And then I've got to differentiate minus 3. Well, that just vanishes. Minus sine x differentiates to minus cos x. So there's my f dashed of x. So therefore, my iteration is going to be xn plus 1 equals xn minus, okay, and on the fraction, the top of the fraction is going to be f of x, except all the x's change into xn's. So that's xn e to the xn minus 3 minus sine of xn, and on the bottom I need to have e to the xn plus xn e to the xn minus cos of xn. Okay, so I've now, fairly horrible looking iteration, but I've now recorded it. So now I'm just going to get my remaining marks for showing that I know how to use it, starting with this starting value, x1 equals 1.5. Now for the first iteration, it's advisable to show all the detail for subbing that in to get x2. So I'm going to sub in 1.5 into every place in the formula where xn appears. So 1.5 minus 1.5 e to the 1.5 minus 3 minus sine of 1.5 all over e to the 1.5 plus 1.5 e to the 1.5 minus cos of 1.5. But in terms of actually doing the calculation, I'm going to do that thing with the calculator and the answer button. I need to start with a previous answer of 1.5. So 1.5 equals 3 over 2. That's the same thing. So that's now stored as the answer. And now I just need to type in this formula here, except every time I get to an xn, I'm just going to type answer. So I need to do answer. Put it where we can see both things. Okay. No. That should be working. Minus a big fraction. And on the top of the fraction, I want answer times e to the answer, and then I need minus 3 minus sign of answer, and on the bottom I need e to the answer plus answer times e to the answer. Oh no, hang on, I've gone wrong there. Answer plus answer times e to the answer minus cos of answer. Okay, that looks all right. And press equals, and that gives me the value for x2. So I'll put it at the end of this line here, 1.255. It says I want to find the root to 5 significant figures. That means I should record more than 5 significant figures in each of the answers I give. So this first one is 1.255239. That's plenty more. Now, to get future answers, I don't have to show all that working. I don't have to do a hell of a lot more typing on the calculator either. I can just keep pressing the equals button. So I'm just going to press this equals button, and it's going to show me that x3 is this. So I'll just copy down 1.195574, and x4 is 1.192455, and x5 equals 1.192443. And just once more, I haven't quite got agreement to 5 significant figures yet. Okay, this 5th significant figure would round to 5 for that one and 4 for this one, and it looks like it's pretty close to the halfway point. Okay, I reckon that this one's going to win. We'll press equals just one more time, and we can see that actually we get almost no change. We're so close to the solution. The closer you get on the Newton-Raphson method, the better, the faster the convergence is. So in fact, x6 is 1.192443 again. It hasn't actually changed to that level of accuracy from x5, so therefore the solution, I can be confident with the first 5 significant figures, 1.1924. Okay, to 5 significant figures, double underline my answer, and I'm happy with that solution. So the key features, okay, Newton-Raphson, you have to start with an f of x that equals 0. You need to show clearly you've differentiated it and how you get from that, using the thing from the formula book, to the full iteration here. The first time you use the iteration, you should earn your method mark by clearly substituting in your starting value. After that, it's okay if subsequent answers just appear. Record them to more accuracy than you need. Okay, check you haven't got the solution to 5 significant figures until you've got 2 answers that clearly agree to 5 significant figures, and then you give your answer to exactly 5 significant figures, because that's what we were asked for up here. Okay.